In this lesson, we're looking at graphing another kind of function. We're looking at rational functions, and that word rational should make you think fractions, and that would be absolutely right. So you can think of rational functions as a function consisting of a fraction of two binomials. We've seen rational functions before. We saw the reciprocal function in last chapter, 1 over x. And that function, like many rational functions, will have asymptotes, which are lines representing important values in the function. So either for x equals a number, being a vertical asymptote, that's where you'll find your infinite discontinuities. So since we're dealing with fractions and you're not allowed to divide by 0, those vertical asymptotes will very likely be found at those points of discontinuity where you could potentially end up dividing by 0 if x equaled that value. Y equals d is the equation of a horizontal asymptote, and that horizontal asymptote is usually kind of given away by the end behavior. And I'll talk about how you're going to determine that end behavior even without a graph. So in example 1, we want to start by finding the domain of the function. Okay, so the domain of this function, well, notice I'm dividing by something, so I better make sure that I don't divide by 0. So if x plus 5 can't equal 0, then that means x can't equal negative 5. So my domain is negative infinity to that negative 5 with a union, picking right back up at that negative 5 and going to positive infinity. But this, notice, is giving me a point of discontinuity. And I told you back here that that's where you're going to have your vertical asymptote. So this anti-equation of x cannot equal negative 5 is kind of leading you into what your vertical asymptote equation will be. Your vertical asymptote will be x equals 5. Negative 5, excuse me. For your horizontal asymptote, you've got to figure out your end behavior. And in order to figure out your end behavior without having a graph to look at, what you want to kind of figure out is if I plug in a very large value for x towards the right, and I plug in a very large value for x towards the left, am I approaching some infinite end behavior like we've seen in previous functions, or am I kind of flattening out towards a number on both ends? Okay, so in order to figure that out, let's set up a table. So I'm going to plug in 1,000 and I'm going to plug in negative 1,000. Okay, so you plug those values into your calculator while I plug it into mine, and hopefully we'll end up in the same place. I plug in 1,000 into this function. I've got 15,000 plus 3 divided by 1,005, and I get approximately 14.9. Okay, so that doesn't seem like anything infinite. Let's see what happens at negative 1,000. So that gives me negative 15,000 plus 3 divided by negative 995, and that's 15.1 approximately. And what I'd hope that you'd realize is that both of these values are really stinking close to 15. So that means my horizontal asymptote is y equals 15. And that's all that they were asking us. The equations of the asymptotes and the domain. We've answered the question. Next example, same process. Let's start with the domain. Uh-oh, but in order to figure out my domain, I got to figure out what x isn't allowed to equal. So let's do that. x plus 4 is not allowed to equal 0, so that means x can't equal negative 4. So I've got some negative infinity to negative 4 with a union, picking right back up at negative 4 and going to positive infinity. As I mentioned in the last example, this anti-equation, if you will, leads right into our vertical asymptote equation, which is x equals negative 4. My horizontal asymptote, I need to identify if there's some flattening out end behavior going on or something else. So once again, I'll plug in 1,000 and negative 1,000 and see what's happening. So I've got my calculator and you've got yours. 1,000 squared minus 1,000 minus 6 divided by 1,004. So that's 995. That doesn't seem like it's flattening to anything. It seems quite large. Let's see what's happening at negative 1,000 for an x value. When I plug that into my calculator, I get negative 1,005 approximately. Okay, so these two are not approaching the same value. They're actually both very large values, positive and negative. So what we're looking at here is as x approaches positive infinity, y is approaching positive infinity. As x approaches negative infinity, y is approaching negative infinity, which means there is no horizontal asymptote. And sometimes that happens. In this next blurb here, I'm kind of breaking down what your horizontal asymptote can kind of be guaranteed to be. Notice here, we notice that there won't be a horizontal asymptote when the degree of the numerator is greater than the degree of the denominator. We just saw that in this example, where this biggest exponent is bigger than this biggest exponent. I'm kind of going through the bullets backwards because I'm seeing where it refers to something that we've dealt with already. So y equals a, where a is the quotient of the leading coefficients of the numerator and denominator when the degree of the numerator and denominator is the same. In plain English, we noticed that here. Noticed how the highest exponent in the numerator is the same as the highest exponent in the denominator. If I take this and reduce it, I get 15. So y equaled 15 was my horizontal asymptote there. My horizontal asymptote will be y equals 0 when the degree of my numerator is less than the degree of my denominator. And in that instance, let me refer you back to that parent function that we dealt with a while back. It looked like this. And look at this line. That's my horizontal asymptote at y equals 0. Notice how this smallest exponent, well, you don't see it, but it's a 0, is less than this highest exponent. Again, you don't see it, but it's a 1. Okay, so that's why that horizontal asymptote was 0. And then once again, it's talking about the vertical asymptotes. And we've kind of already noticed how when I set my denominator kind of not equal to 0, it tells me what my vertical asymptote is. So from here on out, you're going to see me just set the denominator equal to 0 because those are going to give me my asymptotes. On this set of notes, I apologize that I gave you kind of an abundance of space where you really don't need it and not a whole lot of space where you really do. So you might kind of want to get creative with your note-taking here. So I'm going to take the paper and fold it this way so that I can jot down a few things about this graph. And then when we get back here, you'll see there's not really a whole need for this kind of space back here. So that's why we're going to try to maximize the use of it. Okay. For each of these functions, notice that they're telling us that the n is less than the m. In plain old English, that means the degree of the numerator is less than the degree of the denominator. Well, I already told you back here that when that's the case, my horizontal asymptote is y equals 0. Okay, so horizontal asymptote y equals 0. I already know that. Now let's figure out my vertical asymptotes. In order to figure out my vertical asymptotes, I'm going to set the denominator equal to 0. And then I solve for x. Ooh, well, that's a quadratic. Oh, but it factors. So it's x plus 3 and x minus 1. And when we solve that, we get that my vertical asymptotes are x equals -3 and x equals 1. It's also asking me to find my intercepts. Remember what your intercepts are. Your y-intercept is your value of y when x equals 0. Your x-intercept is your value of x when y equals 0. Okay, so let's find the y-intercept. So my y-intercept means I'm plugging in 0 for x. So I'd have 2 over 0 plus 0 minus 3. So that's -2/3. And let's make sure that that looks like a point. It's going to be 0, -2/3. For my x-intercept, I'm going to plug in 0 for y. Well, remember this h of x is y. So 0 equals 2 over x squared plus 2x minus 3. Oh my goodness, Mrs. Clouse, some of you are saying, that doesn't look like any fun to solve. Well, it's actually quite easy. What's in the denominator doesn't really matter as much as what's in the numerator. What I'm aiming for is my numerator equaling 0. And as you can see, this numerator will never equal 0. So there are no x-intercepts. Then it's asking us to graph. Okay, so I'm going to fold the paper back over so I can see this stuff that I wrote down earlier. I have a horizontal asymptote at y equals 0. So that's here. I have a vertical asymptote at -3 and -1. So here's -3 and 1. I have a y-intercept at 0, -2/3, so right about there. And I've got to figure out a few more points here because I don't really know how this graph is going to fit on my grid. I know that graphs tend to kind of hug asymptotes. So once I have kind of a point somewhere in my general regions, then I can just kind of connect the dots and hug the regions and go from there. All right, so I'm going to plug in, I'm going to have a pretty respectable XY table here. I want to see what's happening maybe at x equals -4. I'd like to see what's happening between this y-intercept and this asymptote. So maybe let's plug in -2. Just to be on the safe side, let's plug in 0.5. And then I'll plug in 2, a number after my asymptote on the right. Okay, so again, I'm taking these values and plugging them in for x here in order to find their corresponding y values. So I've got my calculator, you've got yours. -8 minus 3, and when I divide that from 2, that's 0.4, so I could plot the point -4, comma 0.4, that's about here. And as I mentioned earlier, you know that your graph is going to kind of hug your asymptote, so I'm getting really close and getting really close and kind of flattening out. When I plug in -2, I get -2/3, so that's this point here. And these 2 points being kind of on the same level makes me a little nervous. I'm going to plug in -1 also, just so I really know what's going on. Okay, so plugging in -1, I have 1 minus 2 minus 3 being divided from 2, that's -0.5. Okay, so when I plug in the 0.5, I think you'll see it kind of continuing to come down here. But let's verify. So 0.5 squared, 1 minus 3 so that is approximately -1.1. So kind of as suspected, my graph is doing this kind of a thing. And then finally, let's plug in 2 to see whether I'm doing this or this. Okay, so plug in 2, I've got 4 plus 4 minus 3 in the denominator, and when I take that and divide it from 2, I've got 0.4, which is about here. And hug your asymptotes. And there's your graph. And as if this problem hadn't asked enough of us, it's also asking us for the domain. So, spot for it right down here, my domain. Again, notice the arrows. -infinity to -3, union -3 to my next asymptote at 1, union from there to infinity. Next example. Again, I'm going to fold the paper over just so I have a little bit more space to write somewhat neatly what my horizontal and vertical asymptotes are. So again, because my instructions have already told me that the degree of the numerator is less than the degree of the denominator, I already know that my horizontal asymptote is y = 0. In order to find my vertical asymptote, I take that denominator, set it equal to 0. So x squared plus x minus 2 equals 0. It factors to x plus 2, x minus 1. So my vertical asymptotes are x equals -2 and x equals 1. In addition to that, we're being asked for our intercepts. So my y-intercept is what y equals when x equals 0. Well, when I plug in 0 here, I've got 0. Just to be on the safe side, plug it into the bottom, because remember, 0 divided by 0 is not 0. But my denominator isn't 0, so I'm good. My y-intercept is 0, 0, which means conveniently, hey, my x-intercept is also 0, 0. And since this numerator is just x, and x equals 0, I've already covered that here. Okay, so that's the only x-intercept I've got. So let's take all of this information and graph it on our grid. I have a horizontal asymptote at y equals 0, so that's here. A vertical asymptote at -2 and +1, so that's here and here. And I know it's passing through 0, 0. But I want a few extra points just so that I'm confident that I have the general shape of the graph correct. So maybe I'll plug in -3 for x, -1, maybe a 0.5 to see what's happening between here and here, and then 2. Okay, so get out your handy-dandy calculators. When I plug in -3, I get -0.75. So -3 and -0.75, that'd be about here. And then based on that, you kind of, again, just hug your asymptotes. Plug in -1. And I get 1/2. So that's here. I know that it's crossing at 0, 0, but I don't know if it's bouncing back up or going through, so I'm going to plug in the 0.5. And that's approximately, or no, that is -2.4. So that's about here. So I've got kind of almost an odd behavior going on between those asymptotes. And then finally I plug in 2. And that's 1/2. So 2, 1/2 is here. So hug the asymptotes accordingly. And finally, our domain goes from -infinity to my first vertical asymptote at -2, picks back up at -2 and goes to 1, and then picks back up after that asymptote at 1 to go to +infinity. Here we're looking at basically a lot of the same. The main thing you're going to see different here is because the degree of my numerator is the same as the degree of my denominator, my horizontal asymptote won't be at y equals 0. Let's look back at what I said here. It'll be the quotient of the leading coefficients. So the quotient of my leading coefficients for this one is 1. So my horizontal asymptote is y equals 1. For my vertical asymptote, I set my denominator equal to 0. So x plus 2 equals 0, which means that my vertical asymptote is at x equals negative 2. I want to find my intercepts if I have them. My y-intercept would be negative 6 over 2, which is negative 3. More precisely, 0, comma, negative 3. Remember, you find your y-intercept by plugging in 0 for x. You find your x-intercept by plugging in 0 for y. Well, that's here. So what I'm looking for is for 0 to equal my numerator. So x will equal 6 when y equals 0. That's my x-intercept. So let's take all this information we've gotten and graph it. My horizontal asymptote is here. Vertical asymptote here. X-intercept at 6, 0. Y-intercept at negative 3. And these 2 points kind of make it very clear that this is how I'm going to hug the asymptotes on the right. And in order to figure out how you're going to hug the asymptotes on the left, let's plug in negative 3 for x. So when I plug in negative 3, that gives me negative 9 over negative 1, so that's positive 9 right here. So that's the behavior of the other half of our graph. Once again, we're being asked for the domain. So domain goes from negative infinity to my vertical asymptote at negative 2, with a union picking right back up at that negative 2 and going to positive infinity. Last example for this video. I apologize that I printed it such that the other example looks like it's going to be in this video. I just felt like that was a bit too much. So my horizontal asymptote is y equals the quotient of these coefficients. There's a 1 there. So y equals 1/5 is my horizontal asymptote. My vertical asymptote I find by taking 5x squared minus 5 and setting it equal to 0. And that means 5x squared equals 5, x squared equals 1, and my vertical asymptotes are at x equals positive and negative 1. For my intercepts, when I plug in 0 for x, this is 0 and this is 0, so I've got negative 4 over negative 5, so that's positive 4/5. So my y-intercept is 0, 4/5. And when I set up my numerator equal to 0, that's going to help me find my x-intercepts. So x squared equals 4, and my x-intercepts are positive or negative 2, 0. Because I'd have to take the square root of the 4. Because of these fraction values, I'm going to use a scale of... So let's take all this information and put it in our graph. Our horizontal asymptote is at y equals 1/5, so that's here. My vertical asymptotes are at x equals positive 1 and -1. My y-intercept is at 0.4. My x-intercepts are at +2 and -2. So that makes the right and left sides of our graph pretty easy to see how it's going to shape up. And then you might have a educated guess about what's happening between these asymptotes, that maybe it's doing this, but it's good to double check. So let's make a table with 0.5 and -0.5. And when I take that 0.5 and plug it into my calculator, I get 1. So that's about right here. And when I plug in -0.5, I'm also going to get 1, because squaring it yields the same thing as +0.5 being squared. So that's here. Okay, so from there you can kind of see what the graph is doing in between those asymptotes. Finally, domain. So my domain starts at -infinity and goes to my first vertical asymptote at -1, picks right back up at that -1 and goes to +1, where it picks up and goes to +infinity.